Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question paper of Mechanics 1, and the code number of this paper is 9709/42 for the session May June 25. Let's start our session with the first question. First question says a crate is being pushed in a straight line along a horizontal surface by a force of magnitude 25 Newton inclined at 20 degree above the horizontal. The crate moves a distance of 12 meter in 8 seconds with constant speed. Find the constant speed of the crate. So for finding speed, we usually apply the concept of Subert formula. Let's write our Subert formula is S equal to ut plus half a t square. And displace S stands for displacement, which is 12, and time is 8 seconds. So 12 is equal to u into 8, time is 8, and as there is the constant speed, look at this, so there is no acceleration at all. And finally we get, if we divide 12 by 8, it is going to be 1.5 meter per second. That is what our answer should be. And remember, as there is no change in the speed, so initial, whether initial and final velocity, both of them are same. The next question says find the work done by the 25 Newton force. Okay, so for resolving the forces we should have a diagram. Let me draw a diagram on this. The diagram will look like this. From this figure we can see that 25 Newton force is pushing the box to move the crate forward, and the displacement is 12 meter. So we can resolve the forces horizontally. For work done by driving force is equal to, we know the formula for work done is force into displacement. Let us see what is the force. If we resolve the force horizontally, it is going to be 25 cos 20 degree. So please don't get confused with this 25. Don't think that 25 is the horizontal force, not at all, because look at this, 25 Newton is inclined at 20 degrees, so you'll have to resolve this 25 is not directly to be used as horizontal force. So if we resolve the force horizontally, it is going to be 25 cos 20 degree, then it should be multiplied by displacement, and the crate was moved 12 meter. Now if we use our calculator, 25 cos 20 into 12 is equal to 281.908. So 282, we can write 282 joule. This joule is the work done by the driving force of 25 Newton. Let's see what the next question say. The next question says find the power at which 25 Newton force is working. Okay, so for power we know a formula. What is that formula? Work done by driving force is equal to power into time, P into time. So we have already found that work done by the driving force or 25 Newton force is 25 cos 20. For more exact quantity, 25 cos 20, 25 cos 20, which should be multiplied by 12, and power is to be obtained, and time is 8 seconds. We from the question we have seen that it took 8 seconds to travel 12 meter, so we will multiply by 8 seconds. P into p into 8. Now, if we want to isolate p as subject, it is going to be 25 cos 20 into 12 over 8. And then finally our power is going to be, hence power consumed was 35.2 watt. So this is the answer to the final part of this question. Let me show you whole of the solutions at a glance. Well, let's see what is the next question saying. Question number 2 says two particles P and Q of masses zero point 0.2 kg and zero point 0.1 kg respectively are free to move in a straight line on a smooth horizontal plane P. Horizontal plane. P is projected towards Q with speed of 5 meter per second. At the same instant, Q is projected away from P with speed 2 meter per second. When P collides with Q, the particles coalesce. Find the kinetic energy lost during the collision. So it's all about the loss of energy, and we know the components of loss of energy is nothing but the velocity before and after the collision. And for finding velocity before and after the collision, we will have to apply the concept of the conservation of momentum. So let's write the equation for conservation of momentum is mp into initial velocity of p plus mass of q into initial velocity of q equal to mass of particle p and final velocity, that means the velocity after the collision, and mass of q into final velocity of q. Let's see how much is the mass of particle p and q. P and q are zero point 0.2 and zero point 0.1, and the speed after the collision was before collision was 5 as well as 2. Final velocity, I mean after collision the velocity is to be obtained. So it is going to be zero point 0.2 into initial velocity was 5 plus mass of particle q was zero point 0.1, and the velocity of particle q before collision was 2, and final velocity, I mean mass of particle p was zero point 0.2, and final velocity may be, as both p and q together form a new particle, let us assume this to be as r. Then mass of particle q is zero point 0.1 into the velocity of new particle r. So it is going to be on the left side. If you calculate, it is 1 plus 2, that is 1.2. 1.2 is equal to, on the right side it is going to be zero point 0.3 velocity of new particle. Hence our velocity after the collision is going to be 4 meter per second. So finally we are going to find the loss of energy. We know the formula for loss of energy is loss of energy. Loss of energy is equal to negative change in kinetic energy of P minus change in kinetic energy of Q. Well, and the formula is known to us. Formula for kinetic change in kinetic energy is half of m v square. Half of m v square. That means the difference between initial and final velocity of p minus half m of vq square. That means difference between the final and initial velocity of particle q, then square. Okay, so half mass of particle p is zero point 0.2, and final velocity after the collision is this. Initial velocity of particle P was 5. So it is going to be 4 squared, sorry, 4 squared minus 5 squared. So final velocity, remember v square means actually final velocity square minus initial velocity square. Final velocity was 4. So 4 square minus initial velocity was 5 for P, minus, so is the next particle, half of half initial velocity was, sorry, half of m, mass of particle m is zero point 0.1, mass of particle q is 0.1, and final velocity was same, which was 4 square, and minus initial velocity was 2 squared. Now if we simplify this, we will get equal to, that is 25 minus 16, that is 9. So 9 to the 18, that is zero point 0.9 for the first particle, zero point 0.9 minus here 16 minus 4, 12. So 6, that is 0 0.6, 0.6. So loss of energy is 0.3 joule after the collision of both of the particles. Well, that is the final answer to this question, that the lost energy, the quantity of lost energy is zero point 0.3 joule. Let's see the next question. The next question is, a particle P of mass mkg is attached to one end of a light inextensible string of length 2.6 meter. The other end of the string is attached to a fixed point on a horizontal ceiling and the string is taut. The particle is held in equilibrium by a force of magnitude 35 Newton acting in a vertical plane which is perpendicular to the ceiling and contains the string. The force acts in a direction perpendicular to the string. The tension is in the string is T Newton and the vertical distance of P from the ceiling is 2.4 meter. Find in either order the value of M and the value of T. So from the question we have understood that we are going to resolve the forces vertically and horizontally. So before resolving the force, we should draw a proper diagram of the system. Let me draw a diagram. Before resolving the forces, let us find the measure of angle alpha as well as beta. So this is, if we look at the left triangle, here hypotenuse is 2.6 and angle is alpha, whereas opposite is 2.4. So we can write here 2.6 alpha, 2.6 alpha, sorry, sine alpha. For height we write sine alpha. Sine alpha is equal to 2.4, 2.4. Hence alpha is equal to sine inverse of 2.4 over 2.6. Okay, so finally our alpha is going to be, using our calculator, we get alpha is 67.38, 67.38 degree is our alpha. Hence our beta, look at this one is 90 degree. If central is 90 degree, so if we subtract alpha and 90 from 180, we will get the remaining angle. Hence our beta is going to be, beta is going to be Beta is going to be 90 minus 67.38. It is 22.62 degree. So these are the measure of the angles. Now easily we can apply the concept of motion law of Newton for resolving the forces. Let us solve the force first horizontally. So resolving the force horizontally, we'll look at the first triangle. I mean this triangle, we are supposing it to be the first triangle because this is moving onward positive direction of x. So driving force, our concept we are going to apply is driving force minus resistance force is equal to mass into acceleration. Driving force is 35 for horizontal axis, 35 cos 35 cos beta minus this triangle. For this triangle, this is actually our tension. Let me write over here, this is our tension in the string. Okay, so T cos alpha, T cos alpha, and the system is in equilibrium. Look at this, it is written here, the system is in equilibrium, so mass into acceleration is 0, or T cos alpha is equal to 35 cos beta. 35 cos beta. We require tension in the string. So let us find tension. Isolating this as subject, T is equal to 35 cos beta, 35 cos beta, and beta is, the measurement of beta is 22.62, whereas alpha is 67.38. Cos, so for beta, instead of beta we are going to write 22.62, 22.62, 22.62, which will be divided by cos alpha. Alpha is 67.38, 67.38. So finally our tension in the string is going to be, hence our tension is going to be, if we divide this, it is 83.999, 83.999. So instead of that we can use, okay, 999. Hence that means if we round it up to three significant figures, it is going to be 84.0 Newton. N has already been mentioned, so there is no necessity of writing N. So our value of T is 84. Then the next part of the solution is to find M. Okay. So let us resolve the forces vertically. Let me find one space to get it written. I think we can write on the left side. Okay. Let us resolve the forces vertically. So vertical direction, driving force, same concept of the motion law of Newton. Driving force minus resistance to motion is equal to mass into acceleration. So driving force is, for the first triangle, driving force is 35 sine beta, 35 sine beta, plus second one is also above the horizontal axis, so that is also positive T sine alpha, T sine alpha. And now the negative force, I mean downward force is actually P, mass of particle P is M. Okay, so we will have to write here minus mg, minus mg cos, minus mg cos, how much, cos 0 degree. cos 0 degree, because angle is actually 0 degree here, equal to 0. Right side is 0. Now we are going to substitute the values. It is 35 sine angle beta is equal to 67, sorry, 22.62. Beta is equal to 22.62. 22.62 plus tension in the string we have already obtained. It was 83.999, 83.999 sine beta. Beta is equal to 22.62 minus mg. M stands for, m is not given, is which is to be obtained. G, acceleration due to gravity, is 10, and cos 0 is equal to 1, so 10 m. Right side is our 0. Hence we are searching for m. 35 sine 22.62 over this one. If we isolate our m, let us write m on the right side. Then it is going to be, if we write 10m on the right side, it is going to be 10m on the right side positive, and it is unnecessary. Well, then if we isolate m, m is equal to 35 sine 22.62 plus 83.999 sine 22.62 over 10. And using our calculator, we find that m is equal to 9.099. That means if we round it up to three significant figures, it is going to be 9.1. So mass of particle P is 9.1 kg. Kg is already given. So what we can write is only 9.1 as answer. So we got both of the values of tension in the string as well as mass of particle P. Let's see what the next question says. Sorry, we made a great mistake. For the left triangle, it is not sine beta. Both of them are not beta. The left one is sine alpha actually. So here we will have to replace this with alpha. Tension T, beside T, it cannot be sine beta. It is sine alpha. It will be, instead of beta, it is going to be alpha. Okay, it is alpha. Wherever we have written sine beta, it should be alpha. Let us write alpha over here, and the value of alpha is actually 67.38. So here, let me rectify every step. Yes, that is the rectified solution. The first angle is going to be alpha, which is 22.62, and the final angle, I mean left angle in the left triangle, is beta, which is, sorry, left one is uh, alpha. Okay, so alpha is equal to 67.38, whereas beta is going to be 22.62. So let's see the next question. Question number 4 says, a car is traveling along a straight horizontal road. The car passes through a point A on the road traveling at a speed of 15 meters per second and then accelerates uniformly at zero point 0.4 meter per second square for 30 seconds. The car then moves at constant speed for 3t seconds, where t is less than 30 seconds. The car then decelerates uniformly at 2 meter per second square, and after a further t seconds passes through a point B on the road. On the given axis, Sketch a velocity time graph for the motion of the car between points A and B. So we are going to draw a velocity time graph. So our initial velocity when it passes through A was 15. Let us write initial velocity as 15. Then it was moving at a constant acceleration, which is the acceleration is to be obtained actually as acceleration is given as 0.2 meter per second, but we don't know how much is the velocity. So velocity should be found applying this formula. We know the formula is for first phase for 0 0 until 3 seconds, oh sorry, 30 seconds. For 30 seconds the formula final velocity is to be obtained v is equal to u plus a t. Okay, so final velocity is initial velocity is 15 as it is given 15 meter per second when it crosses A, plus acceleration is point 2 and it travels at this rate for 30 seconds. 30 seconds for 30 seconds. 30 seconds. So initial velocity, not initial velocity, when acceleration was point 0.2 meter per second square, our velocity is going to be 15 and 6 sorry, it is not point 0.2, it is point 0.4 actually. Point 0.4 for the first 30 seconds. So it is going to be 12. So 12 plus 15, that is 27. 27 meter per second square. This is for the first phase. That means here it is going to be 27. Okay. Well, then for 30 seconds it is moving onward at constant speed. Okay. So here it is going to be, let us write, after that in the third phase, then the car decelerates uniformly at zero point 0.2 meter per second like this. Okay, now the question is, should we connect this straight line with the horizontal axis? Look at this, it is not given, the time is not exactly given. After a further t seconds the particle passes through a point B on the road. So they have completed the scenario at B, but it didn't come back to origin. I means it didn't come to rest at all. That's why we cannot connect this. This should not be connected. Okay, don't get it connected. Well, now how much is? Let us write the time for 30 seconds. Here it is going to be 30. For first 30 seconds acceleration was zero point 0.4, and then here 3t times, this is 3t, let it be 3t. If this is 3t, so what will happen here? It is 3t 30 plus 3t, 30 plus 3t. Then the final point, let me redraw this. And finally, look at this, it is written for finally, and after a further t seconds it passes through a point B. That means if at this stage it is 30 plus 3t, so one more t is over here. That means this portion is t, so it is going to be 30 plus 4t, 30 plus 4t, 30 plus 40, but still we cannot find the final point because they didn't mention the time when the particle crosses x-axis. That means when the particle was at rest or velocity was 0, nothing has been mentioned. So please don't connect the third straight lines with the x-axis. So that's all about the graph, I mean velocity time graph. Let's see what the next question says. The distance from A to B is 2750 meter. Find the value of T. Okay. So distance means we know the area under the traveled distance. Okay. So whole of this area is actually our total distance. Okay. Now in this total area or total region, there are three parts. So let us see what are these three parts. First of all, we will have to see these parts. This first one is a trapezium. First one is trapezium. Second phase is a rectangle. Second phase is a rectangle. Let us draw the rectangle. This is the rectangle, and the final phase is here. We should not get connect this, but we will have to find the area under the straight lines. That's why we'll have to count this or consider this to be also a straight line. Now we will see whether we do have all of the information provided. For the first triangle, I mean first trapezium, base as well as height are known to us. That means all the information is provided. Then for the second phase, also base and height are given. But for the third trapezium, look at this. We know this time. We know the horizontal line and another vertical line, but the second vertical line, this is not known to us. Okay, so this is not known to us. So for the first of all, we will have to know how much is this height. For this, we are going to apply the formula of Subart formula. Okay, so considering the third phase, I mean third trapezium, here the time is from 30 plus 3t until 30 plus 40. So let us write for 30 plus 3t 3t until 30 plus 40, 30 plus 40. And the formula we are going to apply is v is equal to u plus at, because acceleration is uniform. So v equal to u plus at. U means initial velocity, which was 27. So we can apply that v is equal to, or v is equal to, initial velocity was 27. Already we have found in question number A, it was 27. Plus acceleration. It is not acceleration. Look at this. In the third phase, it was decelerating. Decelerating at the rate of 0.2 meter per second. So let us apply this value, minus 0.2, and t is what? Our t is going to be, the time is for this phase. Look at this, from this to this, it is actually t. So it is actually t. Hence our v is going to be 27 minus 0.2 t for the third trapezium. Now total distance is given. Let us form an equation. Total distance. Total distance. How much is the total distance given? It is given that 2750. 2750. One after the other. If we see the, for the first trapezium, it is base is half of the parallel lines. One is 27, the other one is 15. So 15 plus 27 into the distance between these two parallel lines is 30. Then for the second one is just a rectangle, length into width. So length is 3t and width is, so 3t and width is 30. After that, for the third trapezium, it is sum of the parallel lines are, one is 27. Okay, another one is another smaller one. We have just found it as 27 minus 0.2t. 27 minus 0.2 uppercase t, then into our distance between these two is actually t. From here to here it is actually t. Okay, this distance is t. So let us multiply by t. It is t. Distance between this initial and final point is t, and our right side is equal to what? 6 2750. 2750. Well, here if we simplify, it is going to be 15 into 42. 15 into 42 plus here 313. It is not 30, it is actually 3t into 27. Sorry, here it's a great mistake. It should be 27, not 30, because height was 27, velocity was 27, so let it be 27. Means 81t, then plus here what is it going to be, 54. So let us write 54, that is 27t. 27t minus, if we divide point 0.2 by 2, it is point 0.1. Point 0.1, and if we multiply t by t, it is t squared. T square is equal to 207, sorry, 2750. 2750. Then if we simplify, it is going to be zero point 0.1 t square. 0.1 t square plus 108 plus, sorry, it is going to be 108. 81 plus 27, so 108 t, 8t. Then from 2750, if we subtract 15 into 42, it is going to be negative 2120. 2120 is equal to 0, right side. Then if we multiply each of the quantities, if we divide each of the quantities by zero point 0.1, it is going to be t squared, plus 100, that is, it is plus, here we, it was negative zero point 0.1 t square, so we will have to divide every quantity by negative zero point 0.1. We'll have to divide by negative 1. If we divide, it is, first one is t square, and it is going to be negative, not positive, negative, it is just, there will be one more 0, 1080t, and it is going to be positive again. So if we divide by zero point 0.1, it is going to be plus 2121200 equal to right side. Now we are going to factorize this. If we factorize, our next step can be written over here. So t square, if we divide 1080t, that is, we can write 1060 minus 1060t minus 20t, 20t minus, not minus, plus, let me complete the whole step over here. One more 0 equal to right side is 0. Now if we take t common, it is going to be t minus 1060, and another one is t minus 20 equal to 0. So finally our t is going to be, hence our t is going to be 20. Now you may ask that how can we reject the other value, since we can write, since they have told here, look at this, if you go back to the question, it is written that t must be less than 30. So 1020 is definitely not less than 30. That's why we'll have to write t is less than 30. So our final answer is t is actually 20 seconds. So when the particle was moving at a constant speed, it is 3t, so 90 seconds. So finally 30, it is going to be 120, and it is going to be not 120, 30 and 90, 30 and 60, so 90, and first one is 30, and so 110. Well, that's all about the solution to the second part of this question for finding t, time when the particle was decelerating. Well, let's see what the next question says. Next part says the car continues its journey from B, decelerating uniformly at zero point 0.5 meter per second square until it comes to rest at a point C on the road. Find the total distance from A to C. So from A to B is already given 2.2750 meter. Now we will have to find the final velocity. So our graph looks like this for this portion actually. Let me draw the graph. It looks like this way as uniform deceleration. Yes, it will look like this, and here it was 27 minus zero point 0.2 t. So initial velocity was 27 minus 27 minus 27 minus zero point 0.2 t, and final velocity was 0. So t is actually, we have just found as t is 20. So here our velocity was, initial velocity was 27 minus this is going to be 4, so it is 23 actually. 23 23 was initial velocity. So let us see how much was the velocity. We have already got the velocity as 23. Now we should know the distance. So displacement is equal to Schubert formula is applicable. S is equal to U plus A T. And remember, we are considering these from the third phase where it was 90. The time was what? 3t plus 30, so 60 plus 30, it was 90, and here it was one more t, so 90 plus 20, that is 110. Here 110 was the final time. Okay, so then our s is equal to, initial velocity was 23, we have just, s is equal to sorry, I made a mistake. Ut plus half at square, half at square. So initial velocity is 23, we have already found, and time is from 90 until 110, it is 20 plus, it is not plus, look at this, it was decelerating, moving downward, so negative, it will be negative half, acceleration was zero point 0.2, and t already we have found it is 20 square. Okay, hence our s is going to be it is 460, and here what is 4 and 200, so 200, it is um No, we cannot apply this s equal to ut plus half at square, because actually this is not the time. We don't know the exact time. Let me show you the graph from here. Look at this. When v was 0, that time is not given to us. That means if you extend this line over here, this time, the final time, is not known to us. Okay, that's why we should not. 90 is this one. At this point the time was 90 second. 30 plus not 90, 30 plus 360, so 90 is 90 is over here, and 110 is over here. But the final time, at the time when v is at rest, I mean 0, the time is not known to us. That's why we cannot apply the formula with time. Let us choose a different formula, which is v square minus v square is equal to u square plus 2as. Okay, so we are going to apply that formula. Time can also be obtained, but let us solve in one step. Okay. Is what? As time is not known to us, let us apply v square. V square is equal to u square plus 2as. Final and initial velocity is known to us. Final velocity is 0. Initial velocity was 23 square. 23 square. And as this is decelerating, so negative 2, deceleration was point 2. In the first question we have used this, and displacement is to be obtained. Okay, so it is going to be, our s is going to be negative 23 square, 23 square over point 0.4. Sorry, acceleration is zero point 0.5 over here. Zero point 0.5. Okay, acceleration is zero point 0.5, so it's not zero point 0.2. Let us write 0.5. Then 2 into zero point 0.5 is 1, so it is going to be actually negative 1. Hence our s is 23 square means 529. 529. This is for the final part actually. So total distance is to be obtained. Initial distance, I mean distance in traversed in the first 110 seconds is given. So total distance is equal to 2750 plus 529, equal to, if we add up, it is going to be 3279 meters. So that is the total distance since the beginning of the motion till it reaches C. That means it comes to rest again. Well, so that's all about this solution. Then let's move on to the next question. This is the largest of all questions. It says one end of a light inextensible string is attached to a particle A of mass 3 kg. The other end of the string is attached to a particle B of mass 4 kg. Particle A is in contact with the rough plane inclined at 30 degrees to the horizontal, and particle B is in contact with the smooth horizontal plane. A second light inextensible string is attached to B. The other end of this second string is attached to a particle C of mass 5 kg, which hangs vertically. Both strings are taut and pass over small smooth pulleys and that are fixed at the ends of the horizontal plane. The part of the string from A to the pulley is parallel to a plane of greatest slope of the inclined plane, and A, B, C are in the same vertical plane. The system is released from rest. In the subsequent motion, C moves vertically downwards with acceleration 2 meter per second square, and neither A nor B reach a pulley. Find the tension in each of the strings. So there are two strings. Question is so large, but solution is not so complicated at all. There is no twist. There is a twist, a simple twist. If you can identify the direction, then it gets easier. So let's start the solution. So there are two string. If we identify the string, one string is over here. This is one string attached to B, and the another string is also attached to B, which is moving to the other direction. So let us start the solution. First of all, we will start with C. Okay, so C is actually moving downward. So let us write for C. For C, as direction of the particle C is downward, so we will write driving, and we are going to apply the concept of the motion law of Newton. Driving force minus resistance force is equal to mass into acceleration. What is our driving force for C? It is nothing but the weight. So we will write mg. The driving force for C is just moving down, so that is mg cos 0 degree minus resistance to motion is the tension in the string BC. Let me show you. Look at this. For C, the resistance is this tension. That means tension in BC. For C. For C, actually, this is the tension. Okay. Look at this. BC is the tension. This tension is acting as negative force for C. So we are writing tension in the string BC is equal to, as the system is in equilibrium, so the acceleration is 0, and mass of particle C is 5 kg. Acceleration due to gravity is 10, is equal to, sorry, acceleration, it is not in equilibrium, it was released. Actually, look at this, it is written the system was released and acceleration was 2, so it cannot be 0, rather it is going to be mass into acceleration. Mass is 5. Okay, so 5 into 2, then 5 into 10, the minus 5 into 2. 5 into 2 is equal to tension in the string BC. Hence, our tension in the string BC is going to be 50 minus 10, that is 40 Newton. It is 40 Newton. So, they have told us to find the string, I mean tension in each of the string. So the force acting in the tension string BC is 40 Newton. This is one of the answers. Now for the other particle, for particle B, let's choose for particle B. For B. Now let's see what is the scenario for B. For B, driving force is the tension, I mean string BC, and the resistance to motion is tension in AB. So we are going to apply the same concept of the motion law of Newton, that is driving force minus resistance force is equal to mass into acceleration. Okay, so driving force is, already we have seen that tension in, and here the direction is actually this way. Okay, and for B the direction was downward. Yes, for C. So for B, this is the direction No, not for B. So particle B is being pulled by tension, I mean string BC, and just the resistance to motion is tension in string AB. After that, we cannot ignore the weight also. Weight, as this is for B, it is mg cos 90 degree. Okay, cos 90 degree equal to, because B is lying horizontally on a smooth plane, and acceleration mass is 4, acceleration is 2. Okay, so tension in BC has already been obtained. We can apply that value. Tension in BC is 40, and tension in AB is to be obtained, and mass cos 90 is equal to 0, so it is actually 0 unnecessary to be written. It's equal to 8. Hence tension in AB, if we subtract 8 from 32, it is going to be 40 minus 8 is 32 Newton. So tension in the string is 32 Newton. So that's all about the solution to the first part of this question, finding the tension in each of the string. There are two strings. First we have resolved the forces for particle C, then we resolve the forces for particle B. Then let's move on to the next part of the question, I means for B. B is on the next page. Find the coefficient of friction between A and the inclined plane. So this is for A. For A, we'll have to draw a diagram. Let us draw the diagram. Diagram will look like it is moving upward. Okay. This is what can the system be, and it is all about particle A. Remember, particle A was actually passing through a rough surface. Whenever there is a rough surface, we will have to find the normal reaction. So let us find the normal reaction. R plus 0 is equal to, so this is downward forces. There is no upward force acting on the particle. So downward force is mg cos 30 degree. So this is normal reaction. Hence our R is going to be mass of particle A was 3. So 3 into 10 30. So 30, and cos 30 is square root over 3 over 2. Okay, equal to our R is now 15 square root over 3. Normal reaction is 15 root over 3. Now we can easily apply the concept of the motion law of Newton for A. So for direction of the forces, if we resolve the forces horizontally, it is moving upward. So driving force minus resistance force is equal to mass into acceleration. Okay. So driving force is the tension in AB. So let us write tension in AB. Resistance to motion is actually weight, nothing but weight. So mg sine 30, and there is another resistance to motion, frictional force. So frictional force is mu r equal to mass of the particle A was 3 and acceleration was 2. Then tension in the particle tension in the string AB was 32, minus mass of the particle 3 was 3 tens are 30, sine 30 is half. So 30 over 2 minus mu is to be obtained, and our R is 15 square root over 3 is equal to 6. Hence our 50 mu is equal to, here from 32, if we subtract 15, it is going to be 17. So 17 minus 6 means 11. So it is going to be 11 over 15 square root over 3. 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 Hence our mu is going to be, let us divide 11 by 15 square root over 3 is 0.423. 0.423 is the frictional coefficient of C, sorry, of A, between A and the plane. That is what the answer to the question. Then the final question says, when the system has been in motion for 1.5 seconds, the string attached to A breaks. So this is the point. So first find the total distance. Total distance that A travels up the plane from the instant that the system is released from rest to instant that A comes to instantaneous rest. That means when it was broken or it breaks, then to some extent it moves on. I mean particle A. So let's start the solution. So through a graph we can visualize this. Suppose first, when all the strings were taut taut, then suppose it was, this is particle A, okay? So particle A was at this point when the strings were connected, okay? But at one stage, when the string breaks, then it may reach some distance up to this, okay? Then it came to rest and move it down. So first of all, we should know the distance when the strings was connected. This distance is to be obtained, and for finding distance, as we know, the time as well as initial velocity and acceleration, so we can apply the Subart formula. So the before the string breaks, before the string breaks, displacement s is equal to ut plus half at squared. Initial velocity was 0 because from rest the particles were released, plus half acceleration is already given. Acceleration was 2 meter per second square. It was given in the question, 2 meter per second square, and it was working for 1.5 seconds, so 1.5 square. Hence s is equal to, so initial displacement was 2.5 divided by, so 2 into 2.25, sorry, 2.25 meter is the distance before the string breaks. Now after the string breaks, what does happen? We will apply the same concept of motion law of Newton. It is after the string breaks. The string breaks. So same concept, it moved a little bit, and how much is that? Let us see. Driving force minus resistance to motion is equal to mass into acceleration. Okay, we require acceleration to be obtained for finding displacement. So driving, there is no more driving force. Look at it, when the string is broken, then there is no driving force at all, and resistance to motion is what? That is tension in mg, sorry, there is no tension at all. Mg, that means weight, mg sine theta. Only weight is causing it moving downward. And mass of particle A was, it's all about particle A. Sorry, and there is another resistance to motion, which is frictional force, because the surface is rough, equal to our mass of particle A is 3 and acceleration is to be obtained. Sorry, here we will have to write frictional force. Frictional force is mu r is equal to 3a. Then if we simplify it more, mass is 3, so 30 sine 30 is 2, so 30 over 2, it is negative 30 over 2, minus mu has already been obtained in the previous question. We have found that mu is to be, our mu was 0.423, we have already obtained over here. This is our mu, that means the frictional coefficient, so 0.423, and our normal reaction was mg's normal reaction was 15 square root over 3, 15 square root over 3 is equal to 3a. 3a. We are supposed to isolate A, so A is equal to, acceleration is to be obtained. Acceleration is equal to so negative 15 minus this over 3, okay? Negative 15. Negative 15 minus 4.23, 4 point, sorry, 0.423 into 15 square root over 3, 15 square root over 3 over 3. A whole of this will be divided by 3. Hence our acceleration is going to be point negative 8 point, no, let us write it somewhere else. Hence our acceleration is equal to point, sorry, negative point 8.6632832887. We have taken many more digits after decimal so that we get more appropriate result. Well, now we require actually displacement. So for displacement, we know that v square is equal to u square plus 2as, or final velocity is definitely 0 when it came to rest. Then initial velocity is 3 square. We have found somewhere it is 3. Let us find the initial velocity when the string breaks. It was just here. This is the part we can write beside this. So v square is equal to u square plus 2as. So final velocity is to be obtained. V is equal to square root u. Initial velocity was 0 and acceleration was 2 into, we have found the acceleration which was 2, and displacement was 2.5, we have already obtained, so 2.5, 2.5, okay. Then it is going to be velocity when the string breaks is v is equal to, it is 9, so that is 3 meter per second. So this is the velocity when the string breaks. So initial velocity is 3, so we can use now 3 square here. 3 square plus our acceleration was negative, so it cannot be positive symbol, minus 2 into acceleration was what, 8.6, let us take 7, okay, 6 7, and displacement is to be obtained into s, or s is going to be, or s is going to be 9 over 2 into 2 into 8.7. Hence our displacement after the string breaks is equal to, if we divide 9 by 2.87, it is not 2.87, it is 2 into 2 into 8.67, sorry, 8.67. So 8.67, then finally it is going to be 0.519, 0.519. So this is the displacement it traveled after the string breaks. So this is for the displacement of the particle A after the string breaks, and before the string breaks the displacement was this. Now we can write, so total displacement, hence total displacement, total distance, or whatever you write, total distance is equal to distance equal to, first before the string breaks it was 2.25, 2.25, and after the string breaks it was 0.519, 0.519, 5 1 as well as 9. If we add up these two quantities, it is going to be 2.769, that means 2.77. 2.77 meter is the total distance, which is the final answer. So as my display is very tiny, it looks very clumsy, but since I explained every tiny part, I don't think it's very difficult to understand. Okay, then let's see the next question. I think that is the final of all questions. Question number 6 is on kinematics. It says a particle P moves in a straight line and passes through the point A at time t is equal to 0. The velocity v meter per second of P at time t seconds is given by this. So find the maximum velocity of P in the interval 0 until 3 seconds. We know that for maximum velocity, acceleration is 0. So from velocity, let us integrate this to find acceleration. V is equal to 2t plus 1 3 raised to 2 minus 2t square. So for acceleration, we will find the derivative of velocity, not integration, sorry, derivative. So if we differentiate, it is going to be 2 into 3 over 2, and the exponent is going to decrease by 1. From 3 over 2, if we decrease it by 1, it is going to be half. Minus 2 2s are 4, and it is t. Hence our acceleration is going to be 3 into 2t plus 1 raised to half. half minus 40. And they have told for maximum velocity. For maximum velocity, acceleration is always 0. So let us write for maximum velocity, A is equal to 0. So A means 3 into 2t plus 1, that means square root of this, minus 4t is equal to 0. If we transpose 40 to the other side, it is going to be 2t plus 1 raised to half, means square root, you can write square root also, equal to negative, 40 over 3. Now squaring both sides will get 2t plus 1. 2t plus 1 is equal to 16t square. 16t square minus 16t square over 9. Then it is going to be 16t squared minus 18t plus 9 equal to 0. Now if we factorize this, it is going to be 16 nines are 144 and 24. Sorry, it is going to be negative 9, not positive. So let us write negative symbol here. It is going to be negative. So if we subtract 24 6 from 24, 18t square, 18t square minus 24t plus 6t minus 9 is equal to 0. Now what is common here? 8t is common. If 8t is taken common, then there remains 2t minus 3, and another one is 8t plus 3 is equal to 0. Hence our t is going to be, hence t is going to be 3 over 2. Since the other factor is rejected because t is greater than or equal to 0. So it will be greater than 0, not equal to even. So greater than 0. So our t is 3 over 2 when the velocity was maximum. Now let's see, t is equal to, t is equal to 3 over 2. They have told us to find maximum velocity. Okay, t equal to 3 over 2 when v is equal to, what was our expression? V was 2t plus 1, 2t plus 1 raised to 3 over 2 minus 2t square. So this is our velocity. Or 2t, I think this is unnecessary to be written. We will have to write, you will have to apply the value of t because we have already mentioned. So it should be actually 2, 2t is what? 3 over 2 plus 1 raised to 3 over 2 minus 2 into t square. T square means 3 square over 2 square. 2 square. Then our velocity is going to be, if we simplify this, it is going to be 4 raised to 3. So 8 minus 8 minus it is going to be 20, this 3 square. 3 square means 9. So 18 over 4. 18 over 4. Hence our velocity is going to be from 8. If we subtract 4.5, it is 3.5. So maximum velocity of The particle is 3.5 meter per second is our final answer. Let's see what question number B says. Question number B says, it is given that in the interval 0 until 3, the velocity of P is always positive. Find the distance of P from A at the instant when P is moving at this maximum velocity. Well, so for a displacement or distance, we will have to integrate velocity. So V is equal to, what is the expression for velocity? V is equal to 2t plus 1 raised to 3 over 2 minus 2t square. Okay, now if we integrate in terms of time, it is going to be, they have told that from 0 until 3 seconds, it is 3, sorry, it is v in terms of t, it is going to be from 0 until 3, no, not 0 until 3, it is actually the maximum velocity. They have told that find the distance p from A at the instant when p is moving at maximum velocity. During maximum velocity, actually t was our 3 over 2. So we'll have to write 3 over 2. Here also 3 over 2. Then it is 2t plus 1 if we, it is 3 over 2, 3 over 2 minus 2 integrand t square, and limit is 0 until 3 over 2 dt. Okay, or it is going to be now displacement s is equal to, well, 3 over 2, that is, first of all, this 2 is going to be denominator, and if we add up 1 to the exponent, it is going to be 5 over 2, so 2 into 5. Okay, then our 2t plus 1, the function is going to be how many, 5 over 2, and the limit is from 0 until 3 over 2, minus, here also if it is increased by 1, so it is 3, and it is t cube. Our limit is from 0 until 3 over 2 seconds, or s is equal to, it is 1 over 5, and here it is going to be 2t. If we insert 3 over 2 instead of 2t, so it is going to be 3 plus 1 4, so it is 4 raised to 5 over 2 minus 1 raised to, if t is 0, it is function, the value of function is 1, so 1 raised to 5 over 2 minus 2 over 3. Here if we substitute 3 over 2, it is going to be 3 cube means 27 over 2 cube means 8. 2 cube means 8, and 0 cube means 0. So finally, if we use our calculator, we will find that s is equal to, or s is equal to, it is going to be 1 over 5 into this, 2 raised to 5 is 32, so 31. 31 minus here 54 over 3 8 are 24. Hence our displacement is going to be 3.95. 3.95 meter per second. Sorry, it is displacement, so meter. 3.95 meter is the displacement when the particle was moving at the maximum velocity. Let's see whether there is any part of this question or not. No, it doesn't have any more part. So we are moving on to the next question. The next question says a particle P of mass 3 kg is projected with a speed of 8 meter per second up a line of greatest slope of a rough plane inclined at 30 degrees to the horizontal. P is projected from a point A on the plane and comes to instantaneous rest at a point B on the plane. P then slides back down the plane. The coefficient of friction between P and the plane is square root over 3 over 12. Using an energy method throughout, find the speed of P at the instant it returns to A. Okay, first of all, we will have to show the scenario in diagram. Let us draw the diagram of the system. And concept is already clear. They have already told to apply the energy equation. So let us draw the diagram. So for application of energy equation, we require two components. One is final and initial velocity, and the second information is height. Final and initial height, the difference between the final and initial heights are to be obtained. So before that, we will have to sketch a figure for that. Suppose this is the figure and our angle is 30 degree. It is written 30 degree, okay, and the particle was thrown. Suppose particle was over here and it was projected, then it reached at this. So this is the displacement. Once particle went up to this and then again it came back, to the initial position. And let the distance is not given here, we require the distance, so let it be d. Now, as the surface is not smooth, first of all, we will have to find the frictional coefficient is given. That means normal reaction should be obtained. So, normal reaction is R plus 0. There is no upward force acting on this, equal to mg cos angle is 30 degree. Hence, our R is going to be mass of the particle is 3 kg. So, 3 into 10, that means 30 cos 30 is it is going to be, sorry, it is not cos 30, it is going to be actually yes, cos 30. Sorry, we are finding normal reaction, so that is adjacent. So 30 over 30 and cos 30 is equal to square root over 3 over 2, square root over 30, sorry, 3 over 2, 3 over 2. Hence, our normal reaction is going to be 15 square root over 3. So, we have got our normal reaction. Now, we are going to apply the concept they have suggested, which is energy equation. Energy equation is, work done by driving force minus work done by resistance force is equal to change in GPE, gravitational potential energy, as well as GPE plus change in kinetic energy. Okay, kinetic energy. As the particle was projected, look at this. The particle was projected, so there is no external driving force. That's why it's zero. Work is zero in favor of driving force. Then resistance to motion is work done against resistance to motion. That is mu r into displacement. Displacement has been supposed to be d, so let us write d is equal to change in gp is, okay. Now we will have to find the height also. Let us find what is the height. If this is how much, 30 degree, so this is our displacement and height. So height is going to be h is equal to what, d sine 30 degree. Sine 30 degree. Sine 30 is half. So it is actually d over 2. So our height is d over 2. So change in GP is mgh plus half of mass into final velocity minus initial velocity square. Our mu is already given. Mu is, this one is mu. So square root over 3 minus over 12. Square root over 3 over 12. Square root over 3 mu is square root over 3 over 12. And our normal reaction has been 15 square root over 3 into 15 square root over 3. D is missing, let it be unchanged, and it is definitely negative. Equal to mass of the particle is 3 kg, acceleration due to gravity is 10, and height we have obtained that it is d over 2. Well, it is 10. D over 2, then plus half of mass of the particle. First, the particle went up. So we are finding what was the distance it traveled. Half m is 3 and initial velocity was, look at this, it is given, it was projected at the speed of 8 meter per second, and finally it comes to instantaneous rest. Okay, so final velocity is 0 and initial velocity is 8. So it is going to be 0 square minus 8 square. Okay, so what is it going to be? It is going to be square root over 3 square root over 3. 3, 15, 45. So negative 45 over 12. If we divide 45 by 12, it is going to be 3.75. 3.75. So negative 3.75d, 3.75d equal to, if we transpose this on the left side, it is going to be 330 15d. So minus 15d is equal to what is going to be in the right side, 64 divided by 32. So it is 96. So 96, 96, and it must be negative because 8 square is negative. Hence, if we isolate our d, distance is going to be 3.75 is equal to, our numerator is 96, so we are dissolving the negative symbol from everyone. It is going to be 18.75. 18.75. Hence our displacement is going to be, if we divide 96 by 18.75, it is going to be 5.12. 5.12. So this is our displacement. The particle traveled up and moved down. Well, then as we have already obtained our displacement, so hence h is equal to, hence our h is half of d. Look at this. So it is going to be 2.56. Well, so finally they have told us to find the speed of p at the instant when it returns to a. So now it is coming backward, but we will have to apply the same concept. Okay, so work done by driving force minus work done by resistance force is equal to same concept of energy equation. Change in GPE plus change in kinetic energy. Okay, GPE stand for gravitational potential energy. Well, as we did in the previous case, there is no, still the particle is moving downward, so there is no driving force at all. It is 0 minus resistance to motion is also same, which is mu r then into d, displacement. Work done by resistance force is the normal reaction into displacement, I mean frictional force into displacement. Then GPE is mgh plus half mv square. The same concept we are applying here. Now mu r is our d is equal to what? Let us substitute all of the values. Mu is negative, mu is square root over 3 over 12, square root over 3 over 12 into our r is 15 square root over 3 into d has already been obtained, which is 5.12, equal to mass of the particle is 3, acceleration due to gravity is 10, and now height is we have obtained that height is 2.56. But look at this time the particle is moving downward. As the particle is moving downward, so a final height is less than initial height. That means it is coming downward. That's why height is negative. Negative how much? 2.56. 2.56. 2.56 plus half mv square plus half, our m is 3 and sorry, it is half into 3. Let me write 3 instead of 1 even. So 3 and final velocity. Look at this. Initial velocity was 0 because it reached at constant, at instantaneous rest, then it was coming downward. So initial velocity is 0, that's why it is simply final velocity square. So on the left side it is going to be as usual 1545 divided by 12. Already we have used this information. It is 3.75. So negative 3.75 and then d is 5.12. Let us calculate this. So it is negative 19.2 equal to, if we transpose this on the left side, it is going to be plus. So it is 30. If we multiply 30 by 2.56, it is 76.8. 76.8 equal to 3 over 2 means 1.5. 1.5 v square. 1.5 v square. Hence our v is going to be, if we make v as subject, it is going to be v is equal to, hence our v is going to be square root over 1.5 will go down, 1.5 as denominator, it is 1.5, and numerator is going to be from 76. If we subtract it, 8 minus 2, it is 6. Sorry, yes, it is 6. Then from 6, if we subtract 9, it is going to be 7. Then 112, so 5, that is 57.6. So if we divide 576 by 15, square root of 576 over 15, it will show that 6.20 is our final velocity when the particle was passing A again for the second time. So that's all about this solution. That is what the final answer is. It seems to be very complicated, but not at all. Remember, work energy principle is one of the most important and common part of mechanics. So we should not make mistake in this case. Initially it seems to be complicated, but not at all. So let us go back to the first solution. It was the first solution, then the second, this is also first, then second solution, after that third solution, then fourth solution, then fifth solution, Then the sixth one means question number 5. Then question number 6. It is 5, the remaining part of 5 actually. After that there comes 6. It is all about 6 kinematics. Then the this one is also 6 part, final part of 6. Then 7 is over here. So thank you all for being with me, and may Allah bless all of us with beneficial knowledge. Fi amanillah.